So what we got here is a xforce 2x6. And sorry, my phone's ringing. I think that transistor's popped. I know these two are. That one's burnt and that one's burnt, but I've got to pull them all out. This thing's been apart many times. It's got 5 and H, 8, 7, 8, 9, and 10. This whole combiner circuit here is something I'm not familiar with. So what we're going to do is we're going to strip this down, pull all the transistors out, and we're going to see if we can get this thing back up and running for this guy. Mr. Skid Row, here you go. You crazy ass quarter-mile dragster. Racer, son of a gun. Okay, just give me a second. We'll get started. Okay, so we stripped all the parts out of here that we're not going to use or need to be tested or replaced. And, yeah. Next step is we wash it. So let's go give it a bath. That's going to transform this box. Okay, let's turn the lamp on. This is my favorite transistor checker of them all. Made by Syncor. Turn the light down. Maybe you guys will be able to see the neon bulb in this thing flash. Let's see. Okay. You guys can see that if I turn the lights down. So, this thing was pretty rough. The guy that got this is a super neat dude. He spent a little bit of time on the phone with him. Sorry, super tired. Have you ever had one of those, like a couple days in a row where you've got, your life is so stupid busy that, and it's got nothing to do with work? By the time it comes time to work, you're exhausted. That's where I'm at now tonight, man. I'm not going to be out here for very long, but I got this transistor checker from the guy that first started teaching me about electronics when I was a kid. His name was Mike Cope, aka Martian. This transistor is actually fairly strong. It's got a gain about 28 or so. As you can see, that bulb gets brighter and dimmer and just right about, okay. So our maximum gain's about 30. Now look, I don't get to reuse this transistor. It looks good, it tests good, but I can't actually put it back in this amplifier. Let me explain to you why. This amp has gotten so hot that, as you could see in the previous videos, all the solder that was surrounding it had turned white and ashen. Okay, this thing has been cooked so bad that I went to pull one of the tabs up and the lid popped off. Okay, well, that stresses the leads on the inside of the transistor because now they're no longer supported. So I took super glue and glued the lid back on, and I'm going to return it back to the owner of the amp. But I gotta disregard, I don't get to use that one. A lot of these transistors have been super heat baked. They've been cooked in, cooked down, used, abused, put away wet, rode hard. And if you guys remember from the previous portion of this video, you'll see that about every other one of them was popped. So, not judging my life on 10 ohm smoke alone, we go ahead and we pull all the transistors and we're going to check them all. Now, as catastrophically as this failed, this old school combiner network, they were so close. If they would have had about 3 less turns in here, it would have had the right induction and it might have had a prayer of working. But somebody has gone through and taken this old school xforce. This was post Carl, pre Blue Label. So it's taken this old school xforce and reworked it really hard, and they changed out a bunch of parts. We're going to put it back more like what it was, because that's not actually all that bad. But we're going to go and add all the new modern twists and flavors to it. Score. Hallelujah. Okay, so it's got a gain of 19 on it. No, this isn't the absolute max gain checker. It's not. I got one of those. Okay, so that one's good. It's got a gain of 19. I take my official Jamie and Adam Unleashed Mythbusters Sharpie here. I wrote the gain on it. God, it's been a long day. Okay, so that one's got a gain of about 25 on it. This is just a general means of measure. It's not an absolute means of measure. As long as the gain that I match, you know, the transistor, this transistor, now I got to find one that's close to it. I got to match the two together so they have a close to the same level of gain structure to them. That's all you're really after. It's not the absolute number that you're actually shooting for. So that one's about 28. Now the Sharpie is cute, but it'll actually create a hotspot on the transistor. Call you back because I ain't shooting a video, buddy. I'll have to take some electronics wash and give it a little bit of a bath. Oh yeah, okay. 27. Before I put the heat conductive cream to put this thing back together. You guys aren't going to believe how well this box came out looking on the inside. It looks like new. But then again, if you take 90% of the guts out of any amplifier and decide you're going to replace it with all new equipment, it's going to look new anyhow. So it's about a 26. I've been trying to sit down to do this since 4:30 this morning, and it's now 11:30 at night. Or, pardon me. See how tired I am. I've been sitting down trying to do this since about 3:30 this afternoon. This sucker's dead. 3:30 this afternoon, and here it is 11:30 at night, and I'm finally actually able to get to work. Okay, so we have two match pair. Hopefully I got a used one around here that'll match up with that 19. So this is 2 driving 8. Right now we got a 1x4. Oh, let me go in the house and go to the place where we keep all the happy coupons. Okay, I'll be back. I want to show you guys this. We washed it. And when I mean I washed it, I literally washed every single thing. And I pulled up each one of these positive posts and did a leak down test on each one of these caps. And we even got most of the rust to come off the transformers. So it's going to be relatively new. We are going to reuse the output transformers and reuse all the capacitors here, but everything else I got to build new. My least favorite portion of rebuilding this style of amp is that they left the whole back side of this thing open. So you got 6 fans, and air will always take the path of least resistance, right? Now, because no one has ever bothered to take a minute and focusing on the air moving just down this heatsink that's about this wide, heatsink's about this wide, it comes to about here, there's a big hole back here. And then there's nothing here blocking the big vents down the back side of the box. So what I get to do now, which I absolutely freaking hate doing, is I got to pull these ground leads, I got to pull these 2 tabs that come off the coax connectors, I got to flip the board up, I got to isolate off that vent, and a quarter of this vent. And then I got to create a block on the inside that makes just the air flow down this heatsink. So what you want to do is all the air that comes through this whole cabinet, you want to try and push it out through past this one heatsink. Now, I kind of been toying with the idea, I'm not going to lie, to put a blocker down the middle of the cabinet here. So the transformers, which actually produce the most heat continuously over the transistors because they're continuously working, the most heat continuously, I was going to put a block down this side and make it so that these two fans just cooled this one compartment and then block off that one grill. So it's going to exhaust here, and then have 4 fans pushing down to cool these components and have the air exhaust out the back. But for us to do that for this design, I have to take the whole board up. If that makes any sense. So that's what I'm going to do now. I'm going to go ahead and I'm going to block that off. I'm going to leave that open for the moment, but I'm going to come back to it. And then we're going to start the rebuild process. Look at how hot this freaking board has gotten. It's literally about cooked all the copper clean off the board. I actually need to go in here and do a conductivity test from here to the center one of these posts and see if I don't have to create something else for a ground. Because I mean, it is cooked off. This amp was tore up from the ground up. Okay, so where we left off was I was talking about how we got it all cleaned up. Well, what I've done since then is all the finish and fine work, right? So I went ahead and I replaced the relay, and this one's actually soldered in place. It comes with these little metal feet on it, which makes it very convenient. So we soldered it down. I adjusted the pass-through tune over here, but the main thing that I did is I took this whole board out, believe it or not, and I blocked off all the vents in the back, except for the one right here that comes off the end of the heatsink. And then I took a piece of phenolic and I went this way with it. So now all the exhaust air for this portion of the cabinet has to go down, go through this opening, go across the heatsink, and out. Okay? Now, because we have 5 bad transistors, what we're going to do is we're going to put all the old ones up front that have the low beta gain. So they're going to get the best air. Okay? The newer ones are going to go back here with the higher gain, because this is where it's going to have the most heat. That's going to give this amp the best chance of survival. Now, the other thing I did, which is really big, is I built this blocker. Okay? And what this does is it's going to allow 2 fans to do nothing but cool the bridge network and cool the transformers. Its vent is unimpeded in the back. Okay? So air is going to be able to flow in and flow out. Now, this entire thing was held together with sheet metal screws. Okay? And what I've had to go and do is thread chase all of these PIM nuts. Now I ran short. I'm going to go get more tomorrow and I'll put one in here. But I've re-PIM nutted this whole cabinet, or thread chased it. So when you go and you hold the cabinet down, it's going to be held down with 632 screws the way it was designed, instead of sheet metal screws. So with our blocker in, our airflow is finally right, board clean, new relay, leak down test on the capacitors. Now we can start going and putting good parts back in here. And we're going to start building this thing back up. Finally. I'm not going to lie, I've been so busy the last 3 days. This has been on my bench for 3 days. This is like a day's worth of work. But I've had so much stuff going on that I haven't been able to get here. So I'm going to power on. I'm going to get a lot of this done tonight. So we got to build an input splitter for the 8-pill section. We got to build our 2-pill driver section, replace that capacitor. We got to do our pass around, or from here to here. We got to do our input induction coil over here. So we've got a lot of little things to do. But first step first, I got to replace that resistor, these two, that one there, that one there. Okay? And then we're going to go ahead and we're going to flip our chokes around so they make sense. We're going to build new splitter networks for the input, new combiner networks for the output, new capacitors going to the grounds, new output capacitor, new induction coil, and of course we're going to put the capacitance tube back in it. And then we're going to build our voltage regulator circuit for controlling our fans, because this is an unregulated power supply, and when you turn this thing on, you want it to go, you know, key and sitting there and it's just running. Fans are going at Mach 5, and as soon as you key down, they almost come to a stop. We don't want that. So I got to build a little voltage regulator circuit that's going to sit here that all the fans plug into. But this is going to start going really quick. Really, really, really quick. Okay, that's our update. And when we come back, I will have a block in that hole, and we'll have on-off switches with brand new LEDs in it. Because these are chewed up. we'll be back. I did leave out one real important detail. I flipped this thing on its lid, and I took a hammer full of shot, one of them orange shot hammers, and beat the transformer floor, because this whole side of the cabinet was bent down. I beat all that up so it's now square and sits flush, and the amplifier sits flush on the bench now. It doesn't rock. So, believe it or not, now we're to the easy part. All the details are taken care of. This is going to help it a bunch. It's going to help keep these bridges really nice and cool. It allows us to control the air. It's going to allow more cooling on the output side. But beating the floor so it was square and knocking everything back till it was square, like this was all bent in from the transformers. And the transformers bent down, the sidewall bent in, the back was out of square, the front was out of square. So we're all square again. Everything sits nice and flush on the workbench. Okay, now I can get on to the next step. Well, Mr. D, I finally got the amp turned sideways, and I wanted to get down here and show you how we have this blocked off. So we blocked off this one completely because we don't need to lose all the pressure out that side of the cabinet. But this is going to be your main exhaust port right out through here. And then of course your transformer space, that's wide open, but I don't know if you guys can handle all the sexiness that's in here. I couldn't sleep last night, so stayed up stupid early in the morning, and I finished this thing. So now we got to tune it. But this is every cap pulled off and tested, every pill strip completely cleaned up. From here down is all new transistors. Here up is all beta gain and match transistors. This is your 2-pill driver section, your 8-pill final stage. Good to go. Brand new LEDs. All the holes in the front of the amplifier have been plugged. Your switches have been remounted, of course. All new power wire to the entire thing. All new output network. All new 2-pill driver input network. So how this works is the RF comes off your new relay, comes down, hits this piece of mini coax, comes around, goes into the input transformer, the primary, goes across the 2 drive transistors, comes out, goes past this cap, runs up this coax, comes over here to the stand bar. Then you got your induction coil and your tuning cap. Now it's really important that we put this up off the board, this capacitor, this one right here. The reason I say that is because we want to get it to where we can have air moving around the capacitor to cool it, and we don't want it on the board that's going to transfer heat to the part. Okay, so your RF comes off here, gets split, goes back around, comes to this splitter, which is brand new, comes to this splitter, which is brand new. It's got new 5-watt resistors on it. Actually, I want to change that. That's not my standard. RF comes in, gets rectified, goes through, and I checked all these 330s, checked all the 1000s, they're all up to spec, comes out, goes to your brand new combiner network with your brand new 150 puff capacitors to ground here. Coax comes out, goes to your brand new combiner, comes to your brand new inductor with your capacitance tube. Now, the stock power wires, you only had 2 of these. Okay, now the problem that I have with that is that they bring them around and they hook them down here on the end of the distribution bus. So that means your driver in this first stage of the 8-pill section, so you got 1, 2, 3, 4 stages. These 2 will get the most amperage. So by the time the volts and the amps get down to this end, which is at the end, which is what we discussed is going to be underneath the most punishment anyhow, because the heat is now starving for current and starving for voltage. So these transistors are going to put out more power than these underneath the stock configuration. Hence the reason that these 2 always burned up. So what I've come to do is this network here, this new distribution network. So you've got all these different myriads of wire coming off the bridge rectifiers that are over here, feeding this bus bar. So we'll take from the source, we'll split it up evenly. That way the voltage and the amperage has the same amount of distance to travel. So that means these 2 sections get the same amount of amperage, and also thusly these 2 get the same amount of amperage, these 2 get the same amount of amperage, and these 2 get the same amount of amperage. What that creates is an environment where the voltage stays stable and even to all the different devices. So that way this end isn't receiving all the volts and amps and this end starving. Everything's getting the same. That's another way that you can keep the heat out of it. By upgrading a power wire instead of just using a little 22 gauge piece of wire coming off this bus bar. Yes, that's how they did it for years. Yes, it's cheaper to build that way. Yes, it's quicker to build that way. This will allow each one of these 2-pill sections to do about 10 to 15 more watts bird, and it'll take about 10 to 20 degrees out of the transistor because it's not starving. So we've given it every single possible chance for success. Got rid of all the old junk, put all new in here, cleaned all the old flux and garbage and dirt and filth and grime and grit out of this cabinet. We beat the cabinet back square. The only thing I have left to do now is to tune it, do the test video. I got to clean all the fans, put the voltage regulators in for the fans, and we're done. So now I'm going to get on with the testing portion of it. I'm going to get it all tuned up and running good. So when I cut back here in just a second, we're going to go over the operation. I'm going to show it running with the lid off. Then we're going to put the lid on, put the fans on it, and show you the airflow. All right, Mr. D, I'll be back. Well, Mr. D, you're done. Here's every single part that I changed out, replaced, or did anything with. I'm going to send it back with the amplifier. Oh, I was knocking the pin nuts out of this thing. I went through and I re-pin nut, put new pin nuts all the way through this whole thing. So when you get this back, you're going to have brand new screws on the outside. But brother, this is as cleaned up and as best as it's ever going to get. Is the way it sits right now. Took it all the way down to the board, started all the way over. Brand new LEDs in the front, brand new, brand new. So now let me go over here. We're going to unplug that. So I got room on a wall strip. Okay. Let me run you around the band. 1000 watt slug in 2X. 1000 watt slug in average. 5 watt slug in reverse. Use a 2950 5 watt slug sitting in between the 2x8 and the Bird 10,000 watt dummy load. So, so all we're going to put into this thing for power. We're down on 12 volts, so this thing's doing about 10.5 watts. Believe you me when I say this. I am so excited to be done with this box. So you put this down on 1X. 10 whole watts. Okay. You turn this 5 watt slug around. Dead key and a half a watt. Show our pass-through tune. Not too bad. Not the greatest, not too bad. Remember, there's this preamp circuit that's in the way. So go ahead, we'll turn the amp on. That's not a good test. Just having that dead key down that low isn't that good of a test. So here, we'll run that up to about 200 watt dead key. 200 watt dead key. 600 bird. Land that into the corner till it disappears. So let's put that down on 5X. I don't know if you guys can notice it's getting dim. What's going on is this amplifier is putting such a load on my 110 outlet. This peaking 2500 to 2600 watts. Very, very low drive, Mr. D. Very, 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 very low drive. Now I went ahead, not a big fan of preamps. And what I did is I changed out the amplification transistor that's in here. This transistor that actually does a rectification right down there. I went to one that's got 10 dBs more of receive with a 20 dB lower noise floor. Hence the reason I can turn it on and off, and we're not rectifying that much static. So it's actually going to do you a good job. Now all I had to do to tune this was to slide the tube out and put a little shorten bar in here, and it hopped right up. Input tune. Swinging in reverse. Now let me get down here. Turn on that first supply and this second supply. So now we're going to turn the drive up a little bit. Take the meter. We're back on 1X now. There's our 20 whole watts that we're used to using. Turn the amp back on. $750, almost 800 bird. This thing's working. Now let me get the lid. Okay, so cleaned your fans. I built you a whole new regulator unit to sit up here on the lid, so it's more in the airflow and not down here unsupported, because it's getting a little cluttered up in here. Now, before I go much further, let me get in here. Let me snap us a picture. Okay. Fans are all cleaned. Let's put the lid on. And it runs right off your bus bar. We're all done. Put the lid on it, and we're going to show you running with the lid. And we're done. Okay. Well, everything's 100%. Got this corner all banged back out square. Got this corner all back square. Got all the packing tape glue off the outside. Cleaned up the edges because they were kind of scuffed up. Now this top part, nobody's ever polished it, but this side I got it all cleaned up, all pin nutted with the right kind of screws. It's perfect. Everything on this thing works better or as good as when they built it. I'd go with better. It's just me. Same drive, but that's all she wrote. This project has taken me forever to get done. I've been working on this now. This would be day number 4, and I'm really glad I'm done with it. I've had so many things happen in the last 3 or 4 days that have nothing to do with this amplifier. I can't even go on. I don't even want to burden everybody with it. I'm not going to even talk about it. I'm just going to say I've been busy as hell. Now, some of this video, I'm not going to lie, I shot it at 3, 4 o'clock in the morning, or when I was able to work on it, I only had 3 or 4 hours of sleep, and I'd been awake for 20 hours already, so I might have babbled a little bit, and there might be double redundancy in some of it. But at the end of the day, I got the job done. A complete board-off, complete repair of an old school Carl xforce 2x8. Saved from the trash can. I guarantee you this thing's worth money now, especially with all them brand new beautiful Toshibas in it. Mr. D, you're set. Gentlemen, if you like what you've seen, take a minute, click subscribe. Do me a favor, do the channel a favor. If you like what you've seen, also click like. That's all I ask. Least we can do. One more guy, 10-8 and straight. Come check us out, www.bbiamps.com. Come find me on Facebook, Twitter, Snapchat, Instagram, and of course right here on the YouTube Gargler. Guys, the largest repair shop in the world. I got one more I got to do, and then I got to jump back over and I got to finish up. I got a couple new builds I got to get done. And then I think it might be time to start thinking about doing some new stuff here shortly. That's all I'll say about that. Anyhow, I got to go. Appreciate you guys. Remember, we're all in this battle, this struggle called radio together. I'll see you. Bump, bump.